In this video, we're going to discuss how to figure out the charge on a single atom. So far we've looked at how to figure out the number of protons and neutrons, and now we're going to also look how to figure out the number of electrons, or the charge. Okay, so let's imagine that we're given our standby 12,6C. Well, what do we remember? This is our atomic number, so this is the number of protons. The number of neutrons, let me rewrite this, P equals 6. The number of neutrons is just the mass number minus the atomic number. So the neutrons is going to be 6, right? 12 minus 6 is 6. What about the electrons? Well, let's remember that this is, unless otherwise specified, this is a neutral atom, which means it has a charge of 0. Now, if we remember back from one of the earlier videos, the charge on a proton is positive 1. The charge on an electron is minus 1, and the charge on a neutron is 0. Now, if we have a charge of 0 on the entire atom, and we have 6 protons that are each plus 1, right? So it's really plus 6 over here. How many electrons are we going to have to balance it out? Yes, 6, right? Because we need 6 electrons, which will each give a minus 1, and that will totally balance out with the minus 6, the plus 6, leaving us 0. Let's look at another example of this. Let's say we have 2311 Na, sodium. Well, protons is going to be 11, right? That's the atomic number. Neutrons is just going to be mass number minus atomic number. 23 minus 11, that's 12. Note as well, protons and neutrons are not necessarily equal. Once you get into the teens and 20s of once you get past the teens essentially of the atomic numbers, they're no longer equal. Maybe before sodium they're approximately equal, but after, no. That's why you have to do this calculation. Okay, so protons 11, neutrons is 12. What about electrons? Well, we know this is neutral because it's not said to be plus 1 or anything like that. So we know that the number of protons has got to balance the electrons. So that means we have to have 11 here, because this is plus 11, which means we need a minus 11 to balance it out to be 0. Now, what about if we have charge? So let's take an example of fluorine with a minus 1. And again, they're going to have to tell you that there's a minus 1 charge on it. Well, what about this? Well, protons are still going to be 9. That's always going to be the atomic number. Neutrons, the charge doesn't matter, because remember, neutrons have a 0 charge, right? 0. So we know that it's just going to be 19 minus 9 is 10. What about the electrons? Let's think about this. Well, we have 9 protons. That's a plus 9. We know the total charge of this whole thing is minus 1, which means in order for that to happen, we need to have a minus 10, so that when they add up, we get a minus 1. In order to have a minus 10, that must mean we have to have 10 electrons. And there's your answer. Let's do another example. 16, 8, 0, 2 minus. 2 minus and minus 2, it's the same thing. I just write it 2 minus sometimes. Okay. Number of protons is 8. Number of neutrons is 16 minus 8 is 8. Number of electrons. Well, we have 2 minus extras, so this is plus 8. We have to have a minus 10, which means we're going to need 10 electrons. You can kind of see a pattern here. If you've got a negative charge up here, you have to have extra electrons. So if it's 2 minus, think of it as 2 extra minus charges, so 2 extra electrons. So what happens, though, if we have positive? What if we had Ca 40, 20, plus 2? Well, protons is 20. Neutrons is 40 minus 20 is 20. What about electrons? Well, we have plus 20 here. If we have to have a minus plus 2 overall balance, this is going to have to be a minus 18 in order to leave plus 2 left over, which means we have 18 electrons. Again, if you have plus 2, think of it as plus 2 protons, right? You've got plus 2 extra plus charges. Therefore, you have to have 2 extra protons, which means 2 fewer electrons. You can never change this number, right? Because if you change this number, you change the element. But you can change the number of electrons. Let's look at one more. And that will be 133, 55, cesium, Cs, plus 1. Well, protons are just going to be 55. Neutrons is 133 minus 55. Pop that into your calc, you get 78. What about electrons? Well, we have 1 extra positive charge, which means we have 1 extra proton, so that means we're going to have 54 electrons. And that's about it.